LLMs are these Lego blocks almost that researchers are now using to like piece together like different sizes of LLMs for different steps. And yeah, I'm just really excited to see what this will bring in 2025.
You cannot have a general LLM that just answers like, oh, if you're doing these are the steps. But in fact, you want something that will retrieve the document from the company's documentation and then give an answer based on that documentation. Like for sure, the way Google does things is different from the way Facebook does things, or anyone else basically.
So RAG enables you to implement that local knowledge into a large language model. So it makes it more flexible and it makes it more relevant. Hello and welcome back to Devanddoc, a podcast where developers and doctors join forces to discuss AI and healthcare. I'm your host, Josh. I am a neurologist and AI researcher in London. And with me today is...
And I'm Željko, I'm an AI researcher. So it's been a while since the last time we have done one of these. There have been a lot of changes and new things that came out. To maybe our luck, most of them were like the last 2 weeks, or maybe not the last 2 weeks, but a lot of things have happened in the last 2 weeks. So there is a couple of things that maybe we want to touch upon today, like a bit of the news, what was happening in the world in the last couple of weeks, and then go over to like one topic and discover it like in deep. And today we'll be doing retrieval augmented generation, so RAG.
Yeah, no, that sounds good. Look, I think it's been a good few months, hasn't it, Joko? Like we've been busy with our own stuff. And AI moves at such a crazy pace. Like every single day, I felt like, oh my God, there's so much happening. But yeah, I think what happened in the last 2 weeks really pushed us to get back on the mics.
No, exactly. I think there was one of the new things that came out that I was thinking, oh, this will replace us, because it was called like notebookLM. And it is just something where you upload a paper and it generates a podcast for you. It is until basically until a week ago, it would just generate a 10-minute podcast that is fairly high level and maybe like doesn't tell you really anything, but is just like randomly discussing a topic a bit. So it's not something you can learn from, but it's more something that's a bit like fun, enjoyable to listen. And it's like, it is really good. Like we'll add one snippet here, like a 15-second snippet, just to see like, because there are like, it generates something that has two hosts and they are really holding a conversation. They are interrupting one another. They are like, it feels really like a proper podcast.
Yeah, the conversation flow is amazing. You know, I've fed a few research papers in, and yeah, it feels like an actual podcast. But I would say sometimes it loses some of the point of the actual paper. Like it doesn't really get into the nitty-gritty thing that I want them to get into. They just talk like loosely around it.
Yeah, it doesn't give opinions. Like there is no like, oh, this is the opinion of one of the podcasters. It is more, they're just voicing the opinions on the paper or trying to even justify or talk about the opinions that were given in the paper. But why am I mentioning this? Because there was a fun thing, like they have extended these notebookLM in the past couple of weeks, and now it's much more capable. Now you can go above 10 minutes, you can tell the hosts to focus on a topic. Like you can give much more direction opposite to before, where you could just upload a paper or a text document or whatever. So I don't think this will replace podcasters, but it is an awesome way to learn about things. I found myself like when I'm a paper that I don't think it's that important, but I really want to read it, I would just upload it there, wait for a few seconds, and then listen to the podcast that it has generated.
Okay, that's really exciting. But let's move on to the things that have happened this last 2 weeks. I think there's been a lot of releases from multiple companies. OpenAI are doing the 12 days of Christmas releases. And then Google also dropped their new model.
Yeah, I think, like, in general, I hope things will change for OpenAI. In the next, 5 days, they will announce something awesome, or in the next whatever is left, 7 days are left or something. Because the first part was not that exciting. A lot of the days felt like, oh, this is something we have shown you before, but now it's maybe a little bit better. One of the releases was O1. To me, it was very similar to O1 preview. I didn't see that big of a difference. Some people on Twitter, I'll show again a couple of tweets on screen. Some are giving giant posts and then saying oh, maybe this one is a bit better, this one is a bit worse. But I don't think any one of them are a giant change compared to basically how big of a change was O1 preview to GPT-4. GPT-4 to O1 preview was a big leap, and you could see that, oh, the model is reasoning and the model is thinking during inference time. But
okay, yeah, so this is what I heard as well. O1 is not that different to O1 preview. And if you're interested in the O1 performance for complex kind of reasoning tasks, have a look at our last video where we explored different kind of medical scenarios for O1 and looked at the limitations and strengths of it. I think one thing I did like was I was looking at OpenAI's Canvas mode. I don't know if you saw that.
Oh yeah, the one where it can code together with you or do ideas together with you and edit a canvas basically. And
so it's essentially you're still interacting with the large language model, but it's more of a to and fro. So there's more you can kind of ask it to do one thing, and then you can drag different attachments. You can ask it to edit certain things. I think this is quite interesting. It's changing the model's still probably the same or very similar, but what you're seeing is there's a advancement in how users interact with the model, right? And I think that's quite interesting, and because I think overall, I've also watched. Did you see the Ilya Sutskever talk in Neurips this week? Yeah, and he talks about this. There is a kind of big change in the meta of large language models. Mm-hmm. So historically, we train AI models on the data set, and we improve the internal parameters, and we get it better and better at a certain data set. But with large language models, the idea is these models have so much generalizable knowledge because they're trained on so much data. And the research direction and the product direction now is actually looking at post-training. So once you have these models, how can you use creative ways to then leverage it to do different tasks and solve different problems? So you can see this, right? O1 was a way to demonstrate that, is putting a lot of focus on inference time and trying to see what the model can do without changing necessarily the internal parameters, but seeing what it can do after. And likewise, notebookLM, same thing, right? You're still using a large language model as a base. They don't tell us how they actually do it, but I heard a podcast with the notebookLM people, and they said, yeah, it is a large language model, but they use some kind of to and fro, self-play almost, talking to each other to then reinforcement learning or use some kind of training method to improve the fluency of its outputs. So I think this is a really interesting paradigm that we're seeing that's going on. And AI agents,
yes, another
huge thing that maybe we can talk about in another episode.
Yeah, no, exactly. I just wanted to mention that this is basically going in the direction of AI agents, an AI that gets a task, knows how to use tools, knows how to search the web, knows how to execute actions, has a wide range of options, and is orchestrating all of them to perform a task, to do a job that was given to it or something like that. So I do think like the notebookLM is just that. It's an agent that is creating a podcast.
But what do you think about this new kind of post-training paradigm? Like, do you think it's a bit of a buzz, or do you think it's actually, you know, using LLMs as like building blocks? You can do all kinds of different things. Do you think research is going to head more in this direction?
I mean, I'm sure they can. I just feel like I do think there is a couple of different things, because, for example, the way O1 does things, I don't think that is like fully post-training. You still had to train it to be able for the model to gain the ability to do the inference time reasoning. Like that didn't come out of the box. You basically had to train the model so that it can do that. I also feel like if you want the model to use tools, you still train it on tool usage. Like, I do think it is a bit of a messy area that, which part is post-training, which part is pre-training. But I get what like people like Ilya want to say. Just that a lot of work was done in the pre-training. The models are already very smart. So now we just want to use that intelligence and orchestrate it somehow so that it can perform the tasks that we need.
Yeah, and you know, you can see this in also the Deepmind talks. There's a paper called Promptbreeder, and you know, this is also going into this wishy-washy kind of pre-training, post-training era. But the idea is, I think similar to the prompts episode that we did in the past, the Promptbreeder generates its own prompt and then evaluates the outputs with another large language model, and then essentially evolves it over time to make the perfect prompt, or that's the idea. So what they did in this paper is they took all the popular prompting methods, so like chain of thought, self-consistency, things like that, and then they randomly insert these prompt phrases into the prompts to see if it improves it. If it does, then it evolves, and then they go through the loop again. So it's like an evolution of prompts, and it's kind of cool.
Okay, nice. I mean, I think I saw something similar called like prompt builders, which is just something you work together with an LLM to create the perfect prompt for your task, which I do think this makes quite a bit of sense. Like when you are writing a prompt for your task, I think it makes sense to ask a model like, how can I make this better? What am I missing? Together with the LLM, try to improve the prompt so that it's perfect and it is more in line with maybe what the LLM expects from a prompt. But to go back a bit to what we have seen this week, there is one fun thing I want to mention. That first of all, I love the competition that's happening. Like, I think 6 months or a year ago, you could still say that OpenAI was very much in front of everyone, especially like a year ago. But today's Google is catching up. I feel that Google has completely overshadowed OpenAI in the past 7 days. I think the releases, how it was in the past is OpenAI would release something at the same time or a day after Google to basically overshadow them. Was this intentional or not? That's now a question, but no one cares really.
Definitely intentional.
Yeah. But what was interesting is that when Google released Gemini 1 or 1.5 or something, OpenAI would release GPT-4o. And that would like kill, or would release O1 and that would kill whatever Google has released. But the past 7 days, OpenAI has released the O1 and Google has released Gemini 2.0 Flash Experimental. Whoever is giving these names has no like sense of naming. I don't know what's this about, but whatever. In any case, everything I've seen about Gemini 2.0 Flash, awesome. Like there is a voice demo where I was really thinking, like, when the video started, we'll put like 10-second insert of the video here. When the video started, there is a voiceover, and I was initially like, is this a human or not? Like, it was hard to tell that a non-human is speaking, and the way the voice is being controlled, the amount of expression in the voice seemed really nice.
Yeah, no, it's incredible. And I saw like a meme on the internet, right? Yeah, like Google releasing this new Gemini, and then I think OpenAI was releasing Santa mode on the ChatGPT or something.
Yeah. Yeah, exactly that. It's like one is a Santa mode, one is a completely new model that is multimodal, can handle voice, video, everything else. There is a guy like running around London and pointing at things with the model and talking with it, and Gemini is responding. It just looks very nice.
I saw that, and it works across different languages as well, right? So that was really cool.
Yeah. Yes, there was, in the demo, there was something that at the same time someone immediately switches to French or to Chinese maybe, or any other language, and the model directly responds, keeping the same tone of voice and everything.
Yeah, and I have to say, like, Google's doing really well. So actually, first of all, do you use Perplexity? So that's the retrieval augmented generation search.
Not really. There was, man, I have to mention one more thing from Google. It is annoying. There was just so many things that happened. Now that you mentioned Perplexity, I now started using Google Deep Search or something like that. I'm not exactly sure how is it called, but like you give it a query on a topic you want. So for example, we will now go into, like, the second part of this episode, we'll discuss RAG. I was just thinking, like, what are all the healthcare companies that are using RAG? And I gave that task to Google, and it went and researched like 150, 200 pages. Like, it searched through Google and went through 200 different pages and found any possible links, anything else that is related to healthcare companies using RAG, and then wrote a full-on like 3-4 page document, like a report on the research it has done. Like,
that's amazing. This is research mode, right? Gemini research mode.
That's like deep research mode, whatever. So it can just go in and search like 200 pages and find the appropriate information, and that's awesome.
Wait, this I want to see. Can you show this one?
Yeah, of course. This one we can easily show.
Why do you, I feel like if you share a screen, then that makes it easy for Dragon. You can just literally just like drag and drop this.
Give me a second. I did not prepare to do this.
So I think it's a lot harder for Dragon to like take clips and, you know, from links and stuff of your. It's good when we just show stuff.
No, that's perfect. Let's, what should we give it?
You can do that. You can literally just do the example you just said, since our topic is on RAG.
Brave tab. How is it called? Gemini.
But to get this, you need pro mode, right? Like, you need to pay. Because I tried this, I couldn't get it.
No, you don't. This is without pro mode. So this is just normal. Yeah.
Let me Google it as well. This is great. I'm writing a research paper, so.
Exactly what I was thinking. Like, if I need a research paper on something. So look, this is basically on the Gemini Google Com app. You have a couple of different models, but I'm basically doing the 1.5 Pro with deep research, which means this one is the one that will go in detail and find everything. And now if you want, let's say we want to find all companies that are doing some AI for healthcare. So find me all companies.
There's a lot of companies. It's going to be very
Okay,
busy.
let's not do AI for healthcare.
I think since this
LLMs
episode is on retrieval augmented generation, maybe we should mention that.
Okay. Okay, so let's give it a task on finding all companies that are doing retrieval augmented generation for healthcare.
Perfect. And we'll explain what this is in the episode later. So
exactly. So find all companies that are doing RAG for healthcare. Let's not give it anything else. Like usually I would give a bit more context and be a bit more expressive, or write the prompt a bit more in detail. But let's just see what will it come up with. This will take a second. So what the first thing this model does is it basically writes a research prompt. So based on what I gave it, it will write a full-on research prompt on all the steps that it is going to do.
Oh, so this is a paper, by the way. I'll explain this paper later, but this is based on the paper. this prompt strategy, this decomposition.
Nice. Yeah. So find companies that are. I'll just read through some of the steps. So the first one is find companies that are applying RAG in the healthcare sector. Then the second step is for each company find information about specific RAG solution they offer for healthcare, and so on. So if I'm happy with this, I can start the research. And it will now basically do its thing. This will take a bit. So researching 6 websites, it will find more and more websites. But like this is in essence, in the background, it is just using Google search, writing the search query based on the steps before, and just going through the websites that Google has returned. Now, depending on the difficulty or easiness of the query, it will research only a few websites. Like one of the queries I posted earlier went through like 200 different websites to find the appropriate response. In some cases, maybe it will just do 10 and be like, okay, 10 is enough. I don't need to do more.
But this is similar to what Perplexity is, but I don't think Perplexity searches this many websites. But this is a killer, right? Because if for our listeners who don't know, Perplexity is a search engine that uses this search and then uses a large language model to retrieve that data and summarize it. And it's doing really well. It's growing very fast. But if Google comes out with this, I can just see this basically destroying their business model.
I mean, on one side, I agree. There was, in fact, I saw one comparison between this and Perplexity, because Perplexity has like agents that can go off and do research. This is basically also an agent, just to be clear. Like these devised the steps and then is going through the steps one by one using tools, whatever. So it's basically an agent doing web search. But I think there was one comparison where Perplexity was still a bit better. But also that was just one guy on Twitter claiming something. So I'm not too sure about that. I didn't see any proper research papers on which one is better.
Probably the Perplexity CEO saying that.
Also possible, yeah. But like now we are like researching 132 websites. So it has gone through 132 websites.
And it's taking its time. This is what's interesting, right? It's not just blurting things out like a normal LLM.
No, exactly. Yeah, this one will take quite a bit of time to find everything you can. But maybe, yeah, exactly what I want to say. While we are waiting, do you want to?
Yeah. So look, we don't work for Google. We're not sponsored by Google. Google's not perfect by any means, and we've criticized them in the past. But another release from Google, there was a paper last week. So they had their medical model, MedPalm, and then they have their kind of, they built on top of this to create a LLM called AIME, which is apparently better at maybe solving real world problems. And they applied this to oncology, so cancer patients. And they showed that with 50 cancer vignettes, so like simulated cases. They asked it to recommend different treatment plans and compared that to different doctors on different levels. So there's like more junior doctor, like so one that's not specialized, called a intermediate internal medicine trainee, for example. And then there's a junior oncology fellow, and then there's the attending or consultant that's at the top. So AIME did, as well as the two kind of junior doctors, so the generalist and the oncology junior, but not to the level of the attending or the consultants. Like the paper's not perfect, do these cases simulate real life? Probably not. And they still hallucinated. Actually, there was like a 3% hallucination rate. But nonetheless, it shows, I think, going back to what we were saying, these LLMs have a lot of useful knowledge and data, right? So it's really interesting to see it's before we were saying it's around PhD level, but now applying it to doctors, we can say it's, maybe like junior doctor level of knowledge, which is quite nice.
Awesome. And our researcher is also done. You basically get like a proper document at the output. Will not go through this. I think the quality is decent. It's not the best, it's not the worst, but still it is something that in a couple of minutes went through 150 websites and gave me a report on a basically not an easy question. Like there is an introduction explaining what's RAG, why do people use it, all the good and bad things. Then it goes to companies applying RAG in healthcare. We have IBM Watson Health. We have Key Replay.
Interesting. Yeah, this is comprehensive. Yeah. This is like actual, master's student going away and reading for hours and hours and coming back with this document.
Yes. Yeah, like there are tables inside. There are, for every one of these companies, then it goes into details and tells you something about the company, tells you what they do, tells you like a lot details that me doing these myself would really take me like a day.
I wonder how this would do for like meta-analysis of randomized control trials. Like if you wanted to know if a treatment, what studies there were and if the treatment works. I wonder how it would do.
Yeah, and for what's good is that for each one you will have citations. So for each one of the things it has provided, you have a source page. Where is that information, or all the source pages where that information is coming from. So you basically have references. It's not just random things. So in any case, I don't want to be too much. Yeah, we don't want to sell Google too much, but I think it is awesome. I don't think like this pipeline is that complicated. Just to be clear on that, I think like this is basically something that writes a search query, pastes it into Google, opens Google search results one by one, summarizes the search, like opens the web page, summarizes the web page. If there is important information, then it will add it to a document. If not, it will discard. And it will just repeat these for whatever, 100 pages. So there is nothing too complicated inside of it, but it just works and looks very nice.
Yeah. No, it's perfect. Why don't we go into the nitty-gritty of retrieval augmented generation, or RAG?
I think I've been working with RAG recently, and I was even thinking that what Google is doing here, there is a bit of RAG, but looking a bit online and trying to find information, I think there is no RAG here, and all of it is just really the agent going through web pages. One system that is using RAG is ChatGPT. When you enable the web search, I think I saw some, again, none of these things are 100%, but I saw some claims where people are saying when you enable web search, it basically does RAG over like the whole internet, and or not over the whole internet, but over cached web pages. and then we'll return results based on that.
So what's
RAG?
Well, it's interesting you say that this Google Deep Research isn't RAG, because when I looked at the breakdown, it looks like they're RAG paper.
That is true, but I think there is just a difference on what is doing the retrieval. But let's just go back and explain what's RAG, and then we can maybe just point out the differences maybe between these approaches. So retrieval augmented generation is in fact a fairly simple model, or a fairly simple approach, algorithm, whatever you want to call that, where it consists of like 3 steps. In the first step, we would collect a data set of documents, let's say information about diseases. For each disease we have a document that is describing what's the disease, what are the symptoms, everything else we want. And let's assume we have collected 10,000 of these documents for 10,000 different diseases. Then for each one of these documents, in the most simplest form of RAG, we'll start with that, you would create a vector embedding of the whole document. So you would basically take this document, feed it into a language model that will calculate a vector embedding. The vector embedding is usually a mean pool or an average pool or a max pool of all the vector embeddings of all the tokens. To not go into detail, is basically you get one vector embedding for the whole document. And
it's a numerical representation of the words within that document, essentially.
Exactly, yeah. And you would, in the same sense, embed the whole document, the whole data set. So the 10,000 documents, we would embed all of them. And then in step 3, so step 1 was collect, step 2 was embed, step 3 is now you are asking a query. For example, I'm asking the model, tell me something about diabetes. And you don't want the model to generate the answer just based off of its internal knowledge, but you really want it to reference one of these 10,000 documents that is like properly describing in medical terms what is diabetes. That's all of these documents are like verified, are 100% correct, and so on. So what you do is you take the query that the user has posted, you embed the query also, and then you find the document that is most similar to the posted query. And the one that is the most similar, you basically retrieve it and provide it as the context to the LLM. So then to the LLM you say like, this is the document that you should use to answer this question. And then the LLM will look at the document, will extract the important information and answer the question on what's diabetes.
Yeah. So just to recap, so first step is indexing and embedding. So turning those documents into numerical representations. Second step is essentially query and retrieving. So based on the question, you basically embed that and find the vector representation of that. And you find the documents that essentially are similar in the space. So you retrieve those documents. And then finally is the generation, right? So you feed the documents retrieved into a large language model, which then summarizes it. And the reason we need this, right, is because LLMs are trained on the internet, and whilst it's amazing and there's generalizability there, there's many things in the world which you want more grounding, or you want that data to be more focused on. So this is particularly important in healthcare, right? Because a lot of patient data, healthcare data, is not online. It's, in private servers or whatever.
Yeah.
And also in healthcare, so, you can have an infection, and yes, the treatment would be an antibiotic. But in practice, the question is which antibiotic? Because depending on where you're working, there's local pharmaceutical and formulary guidelines. So, in each region of the UK or India or whatever, you have different resistant to different strains of microbes. So for that reason, you'd opt for a different antibiotic. So RAG enables you to implement that local knowledge into a large language model. So it makes it more flexible and it makes it more relevant.
Exactly. And this is, if we go a bit outside of healthcare, this is also like extremely important for companies. And if they have their own documentation, like a company has, for example, their own rules on how engineers should approach a problem, or how should they submit pull requests on GitHub or something like that. Now, like basically like rules on how to do things. And you cannot have a general LLM that just answers like, oh, if you're doing these are the steps. But in fact, you want something that will retrieve the document from the company's documentation and then give an answer based on that documentation. Like for sure, the way Google does things is different from the way Facebook does things, or anyone else basically.
Yeah, it's great for processes or local like SOPs or, yeah, anything. Like I know a lot of consulting companies now, like McKinsey and whatever else, Deloitte, they are all have like an internal LLM that's has their own internal like company data, their own due diligence and all this stuff. So it's really flexible. It makes the LLM very flexible and much more bespoke for the user.
Yeah, there is in fact one thing that is a bit surprising. RAG did not take off as much as you would expect. Like RAG was something that was basically introduced whatever, a year, 2-3 years ago, whenever, depends like when the real introduction, the real start was maybe a year ago, but if you're looking since when do we know about RAG, then it's 20 years.
Yeah, and that's surprising, right? Because it's so powerful, and everyone's saying, oh, LLMs are hallucinating, they're not grounded. And here you have it, right? A method that, maybe not perfect, and we can talk about that, but a method to ground the model to counter this deficiency. Like, it's weird, because I'm reading AI papers all the time, especially in healthcare and beyond. And every day I'm expecting, okay, surely they're just going to start doing this, using RAG for healthcare purposes. But so far, I can't remember any big papers on this.
No, same. I think there is a lot of papers where people show, like you have the one for Wikipedia where people show like, oh, adding RAG to an LLM reduces the hallucinations to whatever, 1% or something like that, or increases the accuracy to 99%. But no one is still using it properly, so it just means like there is something to it that doesn't really work. Or I think in a lot of cases answering the questions is not as straightforward as you get one document and you answer the question. I just feel like in a lot of cases it's still, oh, maybe you need to take 10 documents and then combine the data from all 10 and then somehow reason on all of them, but plus include external or internal knowledge of the model. I feel like maybe there is more to it, or simply the benefit of having RAG is too small for the general user. I'm sure companies are using it internally, but...
Yeah, but I would have thought, people would put it to research. And that paper you mentioned, we'll link it. It's called Wikichat. And they have like a 7-step process, and they basically use Wikipedia as the ground truth to like ground the outputs in facts. And there's an extra checking step. They use another model to then check the outputs with Wikipedia to make sure that the fact is in fact real. So it's really good. Yeah, maybe there are other steps, but like, do you want to go into some of the limitations of RAG? Maybe that's something. Maybe that's a reason why no one's using it. Do you think it doesn't? Okay, so here's my thought. Right, what if on the retrieval step, like you said, it retrieves the wrong documents, or you have so many things you need to take into account, like in medicine, that maybe it's quite hard to just say, okay, follow this guideline. When the patient comes in, you don't really know what they have, and there may be millions of guidelines. So at what stage do you implement the retrieval may be quite important.
But I feel, okay, maybe just before that, I want to introduce a couple of different types of RAG. Like this naive RAG, the RAG that we initially explained is called like naive RAG. It is the most simplest form of RAG, and in most cases it doesn't work. That's the thing. There are use cases where this will be perfect, and you should really use the one that works. Like use the simplest one that will work for your use case. Like to implement this RAG that we just spoke about is really like 10 lines of code. You don't need no vector databases. Like sorry, I'm jumping a bit up front, but the vector database is something where you will store all of these embeddings of documents that will be like extremely fast, that adds additional features that you might need to retrieve the documents and so on. But this really matters if you have millions of documents. In the case of 10,000, you can really keep them all in memory. If you need to calculate the similarity, just do cosine distance, done. Really, the whole code for this RAG is like 10 lines. There is nothing in it. It is very fast to test and very easy to understand.
Wait, so why does the naive RAG have such a high failure rate? What's the problem there?
I mean, I think one of the biggest ones is you're embedding the whole document at once. And it is very frequent that inside documents you will have many different things. Like if your documents are whatever, documentation about processes in the company, really one document can describe 10 processes. And if you embed the whole document at once, you will lose some information. Like the vector representation cannot hold everything, so you lose a bit of the information that is given in the document.
I see. So it's like taking a textbook or an encyclopedia and trying to squash it down into just a few numbers. Whereas intuitively what you'd want to do is maybe chunk them or like select chapters. Okay, this chapter should be one vector, this chapter should be one vector, or something like that.
No, exactly, yeah. And what you just said is the second version of RAG, chunking. It is one where you take your document, you split it into whatever, 5, 10, 50 pieces, however many you want, or you can also split it by sentence, or you can split it by paragraph or whatever, and then you embed each paragraph separately. There was one approach here that I liked a lot called semantic chunking. I've never heard about this. I was recently working with RAG, a graph-based approach. I'll explain that also. But semantic chunking is really nice. You start by embedding sentences one by one, and you embed the first sentence, then you embed the second one. If the embedding between these two is very similar, you merge them. You calculate one embedding for both of them. Then you embed the third sentence. If it's very similar to the embedding of the first two, you merge them. It is basically a way to almost like, I don't know, is that semantic or is that topic-based chunking or something, where it's just if things are talking about the same thing, should be the same embedding or should be the same chunk.
That makes so much sense, right? I mean, that's almost like what I said, like you take each chapter, but obviously a lot of documents aren't in neat chapters. So if there's a repeat chapter later on and you can actually say, hey, this is very similar to the first chapter, then you semantically link them.
Yeah, I'm sorry if this was not called semantic chunking. I think it is something like that, either like topic or semantic or something chunking. But the approach is this. Other ones are basically in a similar sense. You either just have another model that's detecting sentences or paragraphs, or the document's already split into paragraphs or something like that.
So these are ways essentially to embed and make your vector database, like where you store all the embeddings, as granular and as effective as possible. That's the way I see it. Is that a good way of thinking about it?
Yeah, exactly. I mean, it is a way to try to improve the results, basically, to try to have the representation of the documents to be better, so that it's not one representation of the whole document, but many for smaller parts of the document, so that the retrieval works better. Basically, there's not too much in it. I'll cover just one or two more and then stop there, because there are like 15 of these at least. Like, there is many different types of RAG. The most frequently used one, and the one that people call sometimes advanced RAG, even though advanced covers like many different things, is this one is RAG with re-ranking. So after you retrieve the document, you don't retrieve just one, but maybe you retrieve the top 100 most similar documents to your query. And then you re-rank them using another model that is much more granular. So you would basically then, in the second step, you would take the query plus the document, really the text of the document, feed that into a model that can calculate, basically, can this query be answered in this document? This is called like a re-ranker. I think that's called, how is that called? Like cross-attention or something like that. Cross-encoder.
Interesting.
So the cross-encoder takes two inputs and basically is calculating, are they talking about the same thing? And gives a score. But then this one is now not looking anymore at the embeddings of the document, but it's really looking at the words of the documents that were retrieved in the first step. So it gets much more granular and much more precise.
But is that with an LLM, or is that with another kind of semantic similarity?
It is
search?
Usually another semantic similarity thingy. Like, you can use the T5 model, but there are also LLMs that can do this. So there are LLMs that are fine-tuned to be able to do this cross-encoding.
Okay, so that makes sense. Yeah, so you're essentially, because the embedding vector search is it's not very detailed. So you kind of, it's like saying, okay, I've sensed this question you're asking about, I don't know, head injury. And it's just saying, okay, what are all the documents that are similar? And then you grab all of them. And you probably, depending on how you set the parameters, you might grab too many. So this re-ranking thing lets you essentially pick out the documents that are the most useful. And you do that by narrowing down your attention. Like, from the model, you just look at instead of looking at all the documents, you look at the ones that are closely embedded, and then you basically compare that with the question again, and then you're ranking, like, and you can pick like top 5, top 10 documents to answer that question.
Yeah. In the first step, it's just like hierarchical RAG. In the first step, you retrieve generally the documents that are good. In the second step, you go in detail and retrieve the 5 that are really good. And the last one I'll cover is agentic RAG. This one is the easiest because agentic, again, doesn't mean too much. It just means that there is an agent that can decide to do RAG or not to do RAG. Like, there is an agent that this answers the questions you were asking earlier, like, how does it know to retrieve something? Or what if it doesn't need to retrieve something but can just answer the question based on its own knowledge? Like, if you're answering a question like, who was the US president in the 1980s, whatever, the model can answer that without RAG. He doesn't need RAG for that. So basically, agentic just means the model receives the query, it decides, do I need to use RAG or not? If it needs to use RAG, it can also decide in which way should it use RAG. Should this be a detailed RAG? Should it retrieve the documents and then re-rank them? All of it is basically up to the model to decide.
But that's probably with an LLM, right? That's probably LLM addressing that query, and they know which,
Yes.
and then they direct it to one of the pathways. Do I just go, chain of thought prompting? Do I go RAG? Do I go advanced RAG? That's just probably some kind of lightweight model that has been trained or fine-tuned to decide which pathway to send the user query to.
Yeah, I mean, you have many things. Some people are using really like Claude or ChatGPT or whatever as the agent who is deciding what to do. In some cases, you have a tiny model that just knows to decide is RAG needed or not needed, and then based on that performs the task. So really depends what you need. But yeah, agentic is just combination of other types.
So I read an interesting paper from Google, which is why I said when I was looking at that Google Deep Research, why this is probably an LLM. So this is, I don't know if you saw this paper, but they used problem decomposition. So that maybe I just share my screen briefly. Okay, no, this one. Can you see this? Least to most prompting.
Yes.
Yeah. And I think this is really cool because I think it's like a combination of the last two methods you mentioned. So to me, it's like a mixture of agentic RAG and the kind of re-ranking RAG, right? So what they do, maybe I just share the page after, but you know what you saw with the Google Deep Research bit, and then they break down the question. So let's say you have a question like, which healthcare company is using this AI technique? The model then takes that question and breaks it down. You're basically asking it, what questions do you need to answer to be able to answer that user's query? Break it down into different steps. A bit like chain of thought, actually. But for each of those broken down points, you then do a separate RAG search. And then afterwards, you can combine them and re-rank after. But I think that just opens up the search space. So it really, because once again, sometimes that initial user query doesn't have the exact embedding you want to retrieve the correct document. But if you break down into steps, you might find a more granular output. And this method is, I think the paper showed that it really improves the performance. So it's really interesting.
I think that's great, and that is true. It is very similar to the approach that the deep researcher in Gemini is using. But I just think the difference is that in Gemini, basically the RAG is replaced by Google search. Like RAG is just there to retrieve the relevant documents, and you can replace it with whatever you want. Google search is retrieving the relevant web pages.
Yep.
Instead of really doing like embedding calculation and whatever. But yeah, that makes sense. And in general, I just want to also say that the agentic RAG simply means that an agent is deciding. Like there is an agent that is deciding what type of RAG will I do, everything. Like all is left to it can also be multiple agents. It can be like one orchestrator agent sending off 10 queries to 10 different agents that will run 10 different types of RAG, and then combine the results and return something to the user. So all of this is just more complex systems.
Yeah, I think the last one I wanted to share was just the Anthropic one, which was only published very recently, I think a few months ago. This is contextual RAG, right? So if you, like, my understanding is that, we mentioned before, okay, like you chunk a document and then you embed each chunk. Is a bit better approach than just embedding the entire document. But now what you have is for each chunk, you run it through an LLM and you give the LLM the context of the entire document. And you're just saying that for every chunk, just have a brief summary prompt whilst referring to the original documents and the chunk that you have, just give it a little bit of context, 50 to 100 tokens, and then you embed it with that context. So instead of just a chunk, you have chunk plus context. And I find that this combination gives the embeddings a much richer representation, right? And therefore you can get a lot better output from the model.
I think I get it. I think like if you would describe that in a sense of you reading a book, like if someone just gave you a paragraph from the page 100 of Harry Potter, you would have no idea what's this about. But if then someone prefixed that paragraph with like, oh, Harry is a magician and he's blah blah blah, then the paragraph, even though it is taken completely out of context, would now suddenly start making sense.
Exactly, because if you just chunk sentences, right, you might have a sentence saying that he flew on a broomstick and ate a magic frog. And
yeah,
that sentence by itself would mean, like, would be very confusing. But then if you say, okay, reference this, and then the context would be, oh, instead of he is Harry Potter, the magical wizard boy, flew on a broom and ate a frog. And then suddenly it becomes, okay, that makes way more sense.
Yeah, I agree. I do think that's good. I mean, that's much more data preparation. It means every chunk has to run through an LLM and be contextualized. But I mean, I obviously see how it will work much better than standard RAG.
Look, I think this is really fascinating, and I think it's just to tie it all in. I think we talked about this new paradigm, right? You have LLMs now after the original training run. You're doing all these fun things with it, like, and you can see, like, in all these RAG approaches, you can enrich them with different methods such as semantic, similarity, or more traditional machine learning techniques. But you can also just use an LLM acting as some kind of agent or some kind of arbiter to enrich context and chunking and make outputs better. So I don't know, I find it really fascinating. I feel like LLMs are these Lego blocks almost that researchers are now using to like piece together like different sizes of LLMs for different steps. And yeah, I'm just really excited to see what this will bring in 2025.
No, exactly. And I think we'll have our next episode, which will be review of the year and predictions for what we expect that will happen next year. And I do think exactly what you are saying is one of the big things, like agents, basically. I think 25 is just agents all the way.
Yes, yeah. Stay tuned. But whilst you wait, maybe have a look at our 2024 prediction episode. We made a lot of predictions, and we're going to go over all the ones we got right and all the ones we got wrong. Great. Thank you very much for listening, and we hope we'll see you next time. Perfect. See you on the next one. Bye-bye. All right, bye.